Hi, everyone. Welcome to the final lecture segment of Lecture 5 for Astronomy, Geoscience 160, Life in the Universe. So far in this lecture and the previous one, we've gone from the Big Bang all the way to the formation of protoplanetary disks. And in this segment, we're going to take the last step to forming rocky planets like our Earth. So the question that I want to ask to get you oriented for this lecture segment is, last week, we talked about Cecilia Payne, who later became known as Cecilia Payne-Gaposchkin, who was the first person to really understand that stars are made up of a different mixture of elements as the Earth. We used to think that stars were made up of a similar mixture of iron and silicates that make up the Earth, and the rocks and the materials that we see around us. But Cecilia Payne figured out that the sun was much more likely to be made of hydrogen and helium. And this went against conventional knowledge of the time. So what I want to ask you to think about right now is, why would we have thought that the sun and the earth were made of the same material? Why would that have been a likely conclusion to draw before we knew any better? So to restate that, why is the sun made of different materials than the earth, is a little bit strange when you think about it. So let me explain what I mean by that. So I've showed you this movie once before where we can see how stars and their protoplanetary disks form after being collapsed from a cloud of gas. Now, this gas includes both hydrogen and helium, but also heavier elements like iron, silicon, and magnesium, the ones that were created in the cores of stars and then got blasted out into the universe in supernova explosions, or when the outer layers of stars were shut off. So this gas is made of mostly hydrogen and helium, because that's what most of the matter coming out of the Big Bang was, but with a little bit of trace amounts of these heavier metals that make up the rocks in our Earth. Both the star and the protoplanetary disks from which the planets were formed are made up of this same mixture. So why is it the case that the planets are not made of the same stuff as the sun is? How did the sun, even though it was formed from the same primordial gas as the planets, end up with so much more hydrogen and helium? And the answer to this is that the sun is hot. And in the sun, it's hot enough that everything is a gas. But in the protoplanetary disk, that's just not true. Now, I'll explain what I mean by this. In the protoplanetary disk, you have a mixture of materials. You have hydrogen and helium, but you also have little pieces of silicon. You have little pieces of iron. You have little pieces of magnesium. All of these materials that are kind of bouncing around in this gaseous medium. When the gas cools down, the rocky materials like iron and silicon and magnesium are solid. They are in solid form, and they form into these little grains of dust and rock. But the heavier material, the lighter weight materials like hydrogen and helium remain gas. And materials that have low melting points like water remain in gas form as well, close in the protoplanetary disk. So at the location where Earth formed and where Earth orbits today, the only stuff that was solid in the protoplanetary disk, the only things that were in solid form were rocky materials like iron and silicon. So the idea here is that it's easier for solid material to stick together than gases. So I'm showing here this GIF of Will Ferrell throwing a snowball to illustrate this. The snow on the left-hand side is made of the same material as the steam on the right-hand GIF, but the snowball stays together while the steam disperses. And that's just a general property of solids. Solids stick together better than gases. So if you're trying to form something, you're trying to form a snowball, it's a lot easier to do that with a solid than it is a gas. And that's exactly what happens in our protoplanetary disk. In hot regions of the disk, only rocky materials, the ones that are in solid form to begin with, will stick together. And sticking together little pieces of material is how we build planets. This is why the Earth has much less hydrogen and helium than the sun. Here's a pie chart showing the Earth's makeup. You don't even see hydrogen and helium on this pie chart. Whereas the sun, it's almost entirely made up of this. You have only this tiny little sliver of material, this tiny little sliver of the pie chart that makes up anything other than hydrogen and helium. So the idea is that planets are formed by small particles, the planets in the region of the solar system where Earth formed, in particular by small particles of rock that come together and stick and then slowly grow larger and larger as you add more and more material together. And eventually, if you do this long enough, you can stick together enough material to build up the core of a planet like the Earth. And in particular, you can keep having these collisions until you build up the entire mass of the Earth and end up with a planet like our own.